Okay, guys, I thought I would come on and just give you a quick refresher on um, direct and inverse variation, how it works. You are only supposed to do the odds on this assignment. I apologize. I forgot to put odds before. So if you're just getting to it now, then just do the odds, okay? So in the first section here, you're given a bunch of graphs and you're asked to name the constant of variation and also the slope. Oops. Okay, so your constant of variation, remember the equation for direct. Just write it up here. Direct is y equals kx. So if your equation is written in that form, you're just looking at whatever the coefficient of x is, and that is k. That's your constant of variation. Okay, so remember, k stands for constant of variation. So that's what you're looking for in each of these. I ran out of room for the end. Okay, so for number 1, well, my coefficient in front of the x is just a -1. And then if I take a look at my graph, I'm going to figure out the slope. Looks like I'm going down 1 over 1. So what do you know? It's also -1. Interesting. If we look at number 3 down here, let's see if I can. Oh, jeez. Okay, so on 3, I see that my constant of variation is a -5 because that's the coefficient of x. And then if I take a look at the slope, well, lo and behold, it's also a -5. So you're probably going to realize pretty quickly that the constant of variation and the slope are actually the same. Okay, and if you are ever asked if a graph represents a direct variation, the fastest way to tell is if it runs through the origin. It has to run through the origin in order to be considered direct variation. So, oh geez, sorry, still getting used to, there we go. Writing with the stylus, it's all crazy. So anyway, you can see our 4 graphs. We know that they're all direct variation because they told us at the top. Oh no, they didn't. Oh, well, they should have. So if it runs through the origin, it's direct variation, and k is just whatever your coefficient is in front of the x, which is the same thing as your slope. Okay, and then if you look at this next section down here, these ones you're supposed to tell whether it represents direct or inverse. So let's just throw up here. So we have, oh, geez, direct again was y equals kx. And then let's switch colors. Let's do, yep, okay. Inverse was k equals xy. So remember, those were our 2 equations that we're looking at. So what you need to do for this section, you want to see if you can manipulate the equation that's given to look like either one of these 2. So direct, it has to be y all by itself equal to some number times x. That number could be a fraction, but what you can't have is something like, if you look at number 5, you've got x in the denominator, and you can't have that for direct. Now, for inverse, I just want some number equal to x times y. So if I'm looking at number 5, I'm like, okay, well, I have the 6 divided by x over there. What if I multiplied both sides by x? Then look at what happens. I have on the left-hand side xy equal to, now on the right-hand side, these x's cancel, so I'm left with just 6. So I do have a number equal to x times y. So number 5 is actually inverse. Now, if I can't get it to look like either direct or inverse, then it's neither. Okay, so that could happen too. So if I look at number 7, that you might be feeling like you want to say it's direct, but it's not, because it's not y equals some number times x. It's y equals some number times x squared. And that doesn't fit either one of these 2, so 7's actually going to be neither. 9's pretty straightforward because it's already in, it matches direct form exactly as it is. So that one's going to be direct. And then I bet you already know the answer for 11. Even if I tried the same trick like I did with number 5, if I multiplied both sides by x squared, I'd get x squared y equals 5. And I can't have x squared. I want just x. So that one's going to be a neither. Okay, so that's going to be that section. And let's go ahead and take a look at the next page. I haven't figured out how to erase everything all at once, so I have to do it this way. Okay, let's scroll to the next page if I can figure out how to do that. Okay, so now these word problem ones. So it's what you need to do is you need to be paying attention to if it's direct or inverse, because that's going to change which equation you use. Okay, so if I look at number 1, right away, once I see it says direct, I know I'm using y equals kx. As soon as they say that, I know which equation I'm using. So then I'm going to read, and these were the ones that were really in 2 parts. So if you remember the first part, you use the first numbers that they gave you. So x equals 27 when y equals 6. So let's just plug those in. Y is going to be 6. K, I don't know what you are, but x is 27. Okay, and then I'm going to divide both sides by 27. 6 doesn't divide by 27 nicely, but I can reduce that by 3, so I get 2/9. So it looks like k equals 2/9. All right, and then I have to find x when y is 2. So now the second part comes in. So I go back to y equals kx. I'm not gonna have enough room here. And I'm gonna plug in everything I know now for part 2. So in part 2, right here, I'm gonna find x when y is 2. So I replace y with the 2, k is 2/9, as I just figured out, and then I just have to figure out what x is. Okay, so in order to get x by itself, I'm going to divide both sides by 2/9, which is the same thing, remember, as multiplying by the reciprocal. So I'm going to write over here because I'm out of space. So instead of dividing both sides by 2/9, I'll multiply both sides by 9/2. So I'll do 9/2 times 2 equals x. So I end up getting just 9. Okay, I hope that makes sense. So x is going to be 9 when y is 2. All right, so then you would do that same thing for 15. They're just using z instead of y. Same idea. 17, again, they're just using d's and t's instead of x's and y's. That's fine. But then once you get to 19, so hang on, let's take a look at 19 now. If x varies inversely, so now they're going to be using the inverse equation. So remember that's k equals xy. So as soon as I see inverse, I know I'm going to use that equation instead. So let's see, x is 3 when y is 8. So I don't know what k is, but x is 3, y is 8, which means that k is going to be 24 in this case. All right, so then on to part 2. I'm going back to k equals xy. Now I know what k is, it's 24. And I'm doing this here, find y when x is 4. So I'll plug in 4 for x, and y, I don't know what you are. But I can just divide both sides by 4 and find out that y is going to be 6 in that case. Okay, and then let's erase all this. While we have a moment, I hope everybody's doing all right. We're okay here, hanging in. All right, there we go. Okay, so, oh geez. Oh, I don't think I'll ever get used to this. All right, so let's jump down because there is a question in the odds that deals with squareds, I believe. So let's move, yes, 27 here. Okay, so let's do 27 together. I actually didn't mean to give you one with squares, but since it's on there and it's in the odds, never hurts to have some extra knowledge, right? So let's go ahead and read through 27 together. So this one says y varies directly as the square of x. If y is 25 when x is 3, find y when x is 2. So to do this one, y varies directly as the square of x. So this is saying y is equal to k times x squared. Okay, so this is, it's a little confusing because I know when we were looking up at those, at like numbers 5 through 12, it said, you know, is this a direct or an inverse variation? So those, you can have an inverse variation with a square, it just has to be said so in the beginning. So here it's telling me that there's a direct variation between y and the square of x. Okay, so it's a little bit different than what we were doing before. Okay, so now I'm gonna go ahead and read if y is 25 when x is 3. So let's plug in 3 for x. But remember, this time I'm squaring x. I don't know what k is, so I'm going to figure it out. So 3 squared is 9. So I'd get 25 equals k times 9. And then we'll divide both sides by 9. So I'm going to write it over here because I'm out of room. K in this case is equal to 25 ninths. Okay, and now we're going to do part 2. Find y when x is 2. So I go back to y equals kx squared. And I'm going to plug in find y, so I don't know what y is. K is 25 ninths, and x is 2, but I need to do 2 squared. Okay, so now if I just do that math out, I should get my final answer. So 2 squared is 4, and 4 times 25 is 100. So y would be 100 ninths. Okay, so I hope that makes a little bit of sense. I'm just reading 29. And yeah, we might as well do 29 together because I feel like I'm going to have some questions on that one too. So let me erase this and then I'll scroll up. Okay. Oh, jeez. All right, there we go. Okay, 29. So this one is an inverse variation problem, and they give us that information in the hint. Okay, so that's helpful. It says the distance from the fulcrum varies inversely as the mass. Okay, so let's read through this. Laura has a mass of 60 kilograms and is sitting 265 centimeters from the fulcrum of a seesaw. So if you don't know, the fulcrum of the seesaw is that thing that you teeter on. So it'd be that point right there. It's called the fulcrum. Okay, so they're saying that Laura is over here. She's got a mass of 60 kilograms. She is 265 centimeters away from that fulcrum. So she's sitting back a little way. Now we have Bill with a mass of 50 kilograms. How far from the fulcrum must he be to balance the seesaw? So this is a great question, right? Because they would balance perfectly if they were both 60 kilograms and they both sat the same distance away, but they're not, right? Bill is only 50 kilograms, so he's going to have to sit somewhere else in order to make this balance. Okay, so the question is, where should Bill be? All right, so the distance from the fulcrum varies inversely as the mass. Okay, so the distance from the fulcrum, we're going to go ahead and call that y, varies inversely as the mass x. Okay, so inverse variation, k equals xy. So in the first part, we're going to use Laura as our first part. Mass of 60 and 265 centimeters away. So mass we're saying is x, so we'll put in 60. And she's 265 centimeters away. Okay, so let's just multiply those two together. And we get 15,900. Okay. All right, so now for part 2, again, k equals xy. I know that k is 15,900. X, So now I do know what X is. That's Bill's mass. So Bill is going to go in at 50, and I'm going to solve for Y. So once I do this math, it's going to tell me exactly how far away Bill needs to sit in order to balance the seesaw. So let's see what that gets me. 318. So if Bill just sits 318 centimeters back, the seesaw should be balanced. Okay, hopefully that helps. Let me know if you guys have any more questions. But yeah, okay, talk to you later.